So we are in unit number 5, and we were discussing about the operating systems. We discussed so far what an operating system is, the evolution of operating systems, different types, and also the main functions. We also discuss main functions, and then we also discuss the classification, right? So we discuss there are different way we can, classify operating systems. So next thing that we were discussing last time about how the operating system manage the files and directories, especially within the computer. And we need different file types that we want to discuss. And in a file, we have different attributes, and then we need, file type to recognize. And then we were discussing the file structure, right? So different operating systems we discuss, there are different types. Hari putih, ha. මට ගිහිල්ලා ඔව් හරි පුතේ එහෙම කරු. මම මෙහෙම So in this part, we are going to discuss how we manage processes in a computer. So right now, what we have just seen is in my Windows computer. When I visited the task manager, I can see there are some processes. Under the Google Chrome, I can find there are 35 processes, meeting around 2 processes, WhatsApp 7, which means when you open up a particular program, it may create multiple processes. Right. Now, what is a process then? Now, process means a program in execution, which means it's a particular instance of program execution. When I say program in execution, it means whenever you open a program, it will create one or more processes. So when you open up something in a browser, Google Chrome, for example, it will create a process. So there are different types of processes that are available. Now, some processes are input-output bound processes. Input-output means we work with input-output devices like keyboard, like mouse. So some of the processes, we need this input-output. So we call input-output bound processes. Second type, processor-bound processes. So some of the processes are with the processor itself, right? So I will explain more. Now, when you talk about a process, usually you have a couple of things in a process. You have process ID. Now, if you go to my one, so each and every process, there are some indication, some value, right, given to all these processes, right? We can look at, like, what this information is. We can see the details, right? So you can look at. So you can look at, for example, how much memory it uses, how much CPU it uses, how much disk is uses, how much even network is used. Even the power consumption is given there, right? So you can look at this information here, right? For example, now overall processors, it will show you like how much CPU it's consuming. All the things are given here. Okay. Right now, for example, here it says there are 285 processors are there. Okay. So whenever we create a process, now we know we have to have an ID for this. This ID is to uniquely identify each of this process. Then an executable code, which we will run. When you run it something, you have to have code for this. And data needed for execution. So whenever you run something, you need some data. Then execution context. That means to execute, we need some of other things like program counter, priorities, waiting for input output or not. Now waiting, when you say waiting for input output, when you say waiting input output, it means like you wait for keyboard input. Sometimes you wait for mouse input and so on. Right. Now let's see how the processes are created. The first of all, when you open up a program, right, the process will create usually, right? Or else sometimes operating system create process to provide some service. Like, for example, we can see when you have a printer, to work a printer, you have to create a process for that. And sometimes we create processes whenever you want to run another process, or you are going to start some new batch. Batch job is couple of jobs together. So that's what we will use process creation. So this is how processes are started. At your level, you may think that, okay, whenever you start a program, it will create a process. පුතාලගේ මට්ටමේ දල වශයෙන් මම කිව්වොත් process එකක් create වෙන thank you ප්‍රධාන වශයෙන් ඔයගොල්ලෝ program එකක් open කරද්දි run කරද්දි it will create several processes. The next thing that we want to know is process termination, when process will end. Now sometimes the process terminates once you execute that. Like let's say you open up for something and when you finish the job you can finish it. We call normal termination. So the normal termination means you normally finish this, right? Then sometimes you have a limited time allocated for execution. So that's what you will see here as the second point. Whenever the time is run out, then we will say, okay, time is up, right? Or else another reason might be the resource is not available. Let's say you are waiting for something. So you are waiting for user to input something. And if user doesn't input after some time, you have to terminate the process. Because if user does not respond, then it is not possible to continue. Next, execution errors. If there are some errors when you run a program or run something, then you have to end it. Next, memory access violation. Now, when you say memory access violation, whenever you create a process, that means I told you when you open up a program, you are going to create multiple processes, two different things. Now, when you want to create processes, you have to allocate memories for each of these processes. But the problem is, for each process, we have to allocate memory separately. But if it is violate this rule, we call access violation happens, then we have to immediately terminate the process. Because you allocate some memory and it's fixed. If something goes wrong in the memory, you have to terminate it. Next, operating system or parent process request. Now, sometimes we will forcefully can close the process, right? Now, for example, I will show you. Now, in my case, in my task manager, I can see WhatsApp is running. So if I right click it here, I can say end task. So if I say end task, what will happen? All the processes are gone. It's closed. I have to rerun, right? Similarly, let's take Dropbox. I will say end task. It will remove it from this. And you can see that memory is saved, right? Memory will be saved. Now, right now you can see the maximum amount of memory consumed by Google Chrome, right? So if I click it that, and if I can remove simply by clicking end task, and you will see the memory will drop. If I say click, you can see memory is removed. Now you can see it cleared up some memory. Earlier it was 80%. Now it's about 68%, which is, we'll say we terminated the process. We have terminated, right? Now, similarly, let me, use some of them, right? Let me right click and end PowerPoint. It simply removes, right? Similarly, okay, I cannot remove this one because definitely we need it. So you can see few things we can do, right? I'm going to save. Okay, closed. Okay, now it's not there. So you can see when I terminate, process will leave, right? Now what happens if you have multiple processes? When the main one closes, then the others will also remove. That's what we will say here. Parent process has terminated. So if you close the main one, then all the other processes are also removed, right? So these are the things that we need to discuss, right? Okay, next I'm going to talk about the very important part. So in this part, what I'm going to discuss is I just want to talk about what an interrupt is. Now, whenever you need a operating system attention, we need to create something called an interrupt. Right now, let's say you are printing something. If you have a printer, let's say you are sending a printer to the printer. If there's no paper available, what will happen? අපි print out එකක් ගන්න යනවා printer එකේ papers නැහැ. What will happen? මොනවා වෙනවද? Right. Now, interrupt means, let's say you print something, and if the printer, there's no paper, you have to immediately tell the user that there's no paper. So that means whenever something needed immediate attention, we have to create what we call interrupt. So when we say interrupt, what happens? It will request the change of process. You need some attention, important thing compared to others. So that's why we are creating an interrupts. So when we talk about the interrupts, there are two types. So it could be software, it could be hardware. So both software and hardware can be there, right? We have to handle this. Software interrupt means whenever you have software interrupts, that means basically you are sending interrupt to another process. And hardware interrupt means it's coming out of a hardware. So when I say that the paper is not available, it comes as a hardware interrupt. Right. Now let's look at how we can handle interrupt. Whenever interrupt happens, that means whenever somebody requests priority of CPU, right? So you have to stop the current process. So operating system stop the current process, and then it has to start another process. Basically, in this time, you have to execute the process which generate the interrupt. And then after finishing it, you have to continue from the previous process. So this is called interrupt handling. So maybe we will type that. This is called interrupt handling. Right. Okay, any questions with that from what we have talked about so far? Now, what we just discussed is what process is, and we also discuss what are the things, what will happen when you create a process, process creation, process termination, and finally, we discuss interrupts. Kanta, do you need me to explain anything again? Or is it okay? And if I can continue?
Okay, sir, continue.
Right, okay. The next one, we are going to look at how we manage these processes. Now, remember I told you whenever we open our program, it will create several processes. So in my case, now you can see I have number of processes for Zoom, for Acrobat, for Kaspersky, my internet, for the Word, for the Zoom meeting, and so on. There are a lot of processes are there. So we need to understand how operating system manages all this. So whenever we say the term process management, we talk about a couple of things. We talk about how processes create, right? Right now we know whenever we open a program, it will create several processes. And how it schedule. Scheduling means CPU cannot process everything at once. There should be an order, right? There should be a way of executing them. We call a schedule. Some processes are run first and then you terminate and then you go to the next one and so on. Once you finish the execution, we will call it the termination, right? So when you say process management, we have to talk about process creation, process scheduling, and process termination. And not only that, you have to protect resources allocate for each process. Now, when you say process resources, for each process, we need to allocate few things. For each process, we have to allocate CPU. We have to allocate memory. We have to allocate disk. We have to allocate network. Even we have to allocate some GPU power and so on, lot of resources we have to allocate. So the allocation is important. So we have to protect the resources allocated to each process. That means, let's say you assign some memory to one process, then you should not use that memory to some other process because it's reserved. So that is also comes under operating system. So operating system is the one who responsible for managing all the running processes. And how it done? It is done by scheduling it. Scheduling means you create an order and also it allocates some resources. Right. Now, having said that, let's look at some processor states. Now, processor states means when you create a process, there are a number of stages, number of different things happen to a state, right? So let's see how processor and what are the states. Okay, so this is normally called 7 states of processors. So whenever you create a new process, let's say you open up a program, it will create a new process. And then it can go into ready state. Ready means you will be put into memory and waiting to CPU to execute. So whenever CPU is ready to execute these processes, it will take it to the running state. Running means it's working on a particular process. Once it finishes, it will go to the exit, terminate process. So immediately what we see, you start with the new process, go to ready state. When CPU is ready, you go to running state and then exit. But sometimes the problem is, this is not smooth as per se, not like directly going in this way. Sometimes you have a limited time of running a process. If the time is out, we call timeout, the running will put into ready state and CPU will work on another process. Because remember, it's like you are working with your brain. You can do only one task at a time. So when we have a single CPU, we call, right, it can run only one process at a time. But you have seen there are a number of processes are in our machine. So how it works? Simply, it will take a particular process. It works for some time. And if it is not finished within that time, then it will put in the ready state, takes the other process. So that's how it goes. Right? And sometimes, these processes can go from running to block state. Now, for example, let's say you are trying to get some input from a keyboard. Whenever you wait to get some input for the keyboard, then you are waiting for some particular event. So you put into block state. So block state means operating of the process. It will be in running state, but then it requests to get some information, let's say, put from a memory, right? Or keyboard. So in that case, it will go to the block state. And whenever event occurs or whatever the information, if it received, it can go back to ready state. Right. There are two other state as well. We call ready suspect or block suspect. Now, if the process in the ready state for a longer period of time, then we have to put it into a virtual memory because we need, there'll be multiple processes. We might not have enough, space there. So what happens is put into suspend state. Basically, we can say it's in the virtual memory. Virtual memory means it might be in like a hard disk. So similar thing can happen when you have block state as well. Block state means your process is waiting for some input and output, some activity. And if it is, stay in this place for a longer period of time to save the memory, we will put into virtual memory. Right? And then sometimes this can go up to ready suspend from block suspend, right? And this is, we have 7 state. So usually we will see this is a 7 state process state diagram. Okay, so I have given you some labels, what will happen. New state means newly created process. Ready state means one you have processes in the memory, it will be in waiting. Waiting means ready. And whenever CPU is ready, then it will put into running states, right? And it will allocate everything. But if the time exceeds, as I told you earlier, you have to go back. You have to be in red or blocked state. Ready, okay. Back to ready, it should be ready. Ready or block state. That is what we call running state. Then block state means whenever you wait for input output, keyboard input, disk access, then you put a block state. Whenever you have a memory, resources are available, then it will move back to ready state, right? So it moves to the ready state. Terminate, we have discussed if everything is completed, we can go to terminate. Or ready suspend means you're ready for some longer period of time, and then it will move to the virtual memory. See, goes with the block suspend. When memory is not enough, then process may swap out of memory, virtual memory to, that means the secondary storage. Right. So these are the 7 states. And in exam point of view, normally they will ask to compare the different states. And sometimes they will give you the diagram and they will ask you to draw the points. Right. Hari putih mono hari අපහැදිලි කරක් තියෙනවද මේ ඩයග්‍රෑම් එකේ?
නේද මම ආය බලලා තිබ්බොත් අහන්න.
ඔව් මේකේ මම සරලව සිංහලෙන් කිව්වොත් අපි ප්‍රෝග්‍රෑම් එකක් රන් කරද්දී ප්‍රොසෙසර්ස් ගණනාවක් හැදෙනවා. ඒ ප්‍රොසෙසර් එකක් හැදෙනකොට ප්‍රොසෙස් එකක් අපි ඒක කියනවා new state කියලා. එතෙන්ට තමයි ඉස්සෙල්ලාම එන්නේ. ඒ new ආවට පස්සේ process එක create වුණාට පස්සේ ඒක යනවා ready state එකට. හැබැයි තාම මේක run වෙලා නැහැ. run වෙන්න CPU එක යා run කරන්න ඕනේ. CPU එක මෙයා run කරන්න ගත්තාම ඒක යනවා running state එකට. වැඩි ඉවර කරාට පස්සේ ඒක යනවා terminate එහෙම නැත්නම් exit state එකට. සාමාන්‍ය හැමදේම හරියට වැඩ කරොත් මෙන්න මේ route එක යනවා. new වෙනවා, ready වෙනවා, running වෙනවා, exit වෙනවා. right. සමහරට වෙන්න පුළුවන් දේ තමයි මේ run වෙන process එකට තියෙන time limit එක. we call time out. ඒ කියන්නේ අපි operating system එකක් ගත්තාම ඒකේ තියෙන්නේ හැම process එකම limited time එක. විශේෂයෙන් ඔයාගේ තියෙන single CPU එකක් නම් වාට එක සැරේ කරන්න පුළුවන් එක වැඩක් විතරයි. අපි හිතමු ඔයාගේ තියෙන single CPU එකක් නම් එක සැරේට කරන්න පුළුවන් එක වැඩයි. ඒ කියන්නේ ඔයාට හැම වෙලේම වැඩ කර ඉන්න බෑ එක වෙලා එක වැඩක් එක්ක. ඒකට කිසියම් කාලයක් දෙනවා. කාලේ අවසන් වුණාම එයා යනවා ready state එකට. සමහර අවස්ථාවල වෙන දේ තමයි මේ running state එක තියෙන එකට මොන හරි දෙයක් එළියෙන් ගන්න ඕන වෙනවා. අපි කියන input output. උදාහරණයක් keyboard එකේ මොන හරි type කරනකම් අපි බලන් ඉන්නවා. එහෙම වෙන state එකක් තිබුණොත් අපි ඒක යනවා block state කියන එකට. block කියලා කියන්නේ you are waiting for some input output operation. ඒ වැඩේ හරියට වුණාම ඕනනම් ආපහු මේ ready state එකට යන්න පුළුවන්. දැන් ready state එකේ මම කිව්වා process ගණනාවක් තියෙනකොට එක process එකයි run වෙන්නේ. අනිත් එකේ ඉන්නේ ready state එකේ. හැබැයි ready state එකෙත් අපිට ගොඩ වෙලා ඉන්න බෑ. If it exceeds time limit, then it will go to ready suspend state, which means you will put into virtual memory. Virtual memory එකට දානවා. ඒ කියන්නේ hard disk එක උදාහරණයක් විදිහට මේ අවශ්‍ය මේ ඉඩපාඩු තර සටහන් කරලා තියෙනවා. ඊළඟ එක තමයි සමහරලාට block state එකෙත් ගොඩක් වෙලා හිටියොත් it may also go to blocks and suspend state, which means you will put into virtual memory. And then if the event occurs, then it can move from block suspend state to ready suspend state. හරිනේ කාන්ත එහෙනම් මම දල වශයෙන් ඔන්න පැහැදිලි කරා.
හරි සර්.
right මට පුතාගේ වචන වලින් කියන්නේ දැන් running state එකේ මොනවද වෙන්නේ?
running state එකේ process වෙන්නේ.
ඔව්. CPU එක process එක execute කරමින් ඉන්නේ. right. එතකොට මම කියුවා ready state එක කියලා කියන්නේ
CPU එක මේ process එක ගන්නකම් waiting.
right exactly sometimes wait කියලා කියනවා තමයි. ඔව්. you are in ready state. block state එක කියන්නේ මොකක්ද?
run වෙන process එකක් මැද්දෙන් input එකක් ගන්න උනහම
right. So whenever you wait for some input output, then we can put the in the block state. මං හිතන්නේ ඔයාට අවබෝධය තියෙනවා බොහොම හොඳයි. right. එහෙනම් මම ඊ ටික පුතේ එතන දාලා තියෙනවා. right. Now let's look at how processes are changing. Now when you change a processor, right, from one to another, we call process transition. right. දැන් අපි එහෙම ඒවා කීපයක් කිව්වා. දැන් running state එකේ තියෙන එකක් අපිට යන්න පුළුවන් block state එකට. right. input output එකක් වෙනවනම්. හරි. එතකොට මේකට අපි තොරතුරු ටිකක් තියාගන්න ඕනේ. මේ මොකද ඒ තියෙන process එකේ තියෙන කොතනද ඉන්නේ කියන තොරතුරු තියාගන්න ඕනේ. ඒක තියාගන්න තැනට අපි කියනවා process control block or PCB කියලා කියනවා. So whenever for each process we have something called a process control block and we have to store the following information. What are the following information? Right? Now for example, we have to have process ID. Right? And then we can have process state. Process state can running the blocking the waiting. Then usually in CPU there are small memory locations we normally call registers, and then we will also have what we call the program counter, which indicates where you are in the program. Right? This should be saved. And then the program counter, as I told you earlier, which contains where the next instruction address is. Then we have to have CPU scheduling information, that means priority information. I told you when you have a multiple processors, sometimes there will be an order. සමහර ඒවාට priority දෙනවා, සමහරට නැහැ. තෙල් පෝලිං කිව්වහමත් සමහර රජයේ අයට ප්‍රමුඛතාවය තියෙන ප්‍රමුඛතාවය දෙන අවස්ථා තියෙන අනේ වගේ. So some processes take priority. So that priority information should be there. Then we have to have memory management information. එතකොට මේ මෙමරි එක ඇතුලේ අපි virtual memory එක උදාහරණයක් විදිහට ඒ වගේ වෙන් කරලා තියෙනවා නම් ඒවට අදාළ තොරතුරු page table වල memory limits අපි තියාගන්න ඕන. Then accounting information, user and kernel CPU time ඒ විස්තර තියාගන්න ඕනේ. Input output status information, device allocated, etc. The process control block කියලා කියන අමුතු දෙයක් නෙමෙයි පුතේ මෙන්න මේ වගේ process state එක, process number එක, program count එක, register details, memory limits අනේ වගේ ඔක්කොම තොරතුරු මේ එක තැනක රැස් කරනවා කියන එක තමයි මෙන්න මේ process control block එකේදී වෙන්නේ. Right. The next one, context switching. Context switching means අපි process එකක ඉඳන් අනිත් process එකකට මාරු වෙනකොට සමහර process එක ඉවර නැහැ. ખાલી ඉවරයි. එහෙම නැත්නම් සමහරට අපිට priority දෙන්න වෙනවා. එක process එකක් කියනවා මට execute වෙන්න ඕනේ CPU එක time එක ඕනේ කියලා. Then that changing context, changing process to another process we call context switching. Now the context switching means you are saving context of one process and then you get a context of another process. So this is called context switching, right? So when you have the context switching, what happens once you finish the second process, then after finishing that one, you can continue from where you have stopped in the first process. So this will give you multiple processors to share single CPU, especially when we had uniprocessors. We were discussing how we manage processing in the computer by operating system. So the process is whenever you open up a program, it will create several processors. Right? Then we discuss there are sometimes processors request immediate attention, which we call interrupt. Right? So interrupt means like particular process requests immediate attention from the operating system. And then we were discussing process management. Now each process, it has several different states, which we call process states. How many process states we discussed, Kanta?
7.
There are 7 process states as new, ready, running, exit, blocked, ready, suspend, and block, suspend. Right? And then we discuss what those different states means. And the next one we were discussing is process transition. Now we know sometimes processes might change from one process state to another process state. Now to keep track of this information, we keep everything in a place called process control block or PCB. Right, this is where we were discussing last time. So whenever a process changes from one process to another, we have to keep track everything about the previous process, and then you have to move the execution to the other process, which we call context switching. Now, using context switching, we can have multiple processors to share a single CPU, because when you say single CPU, for a given time, it can run only one process, right? So whenever you need multiple processors, you have to share it. Right, now, whenever CPU switch from one process to another process, we have to have the context switching. In context switching, what happens? It will save all the content, right, of the process you are going to remove, and then you are going to resume after some time. It's a overhead. That means it's an additional, work right? So that means whenever the number of context switches are happen increases, it reduces the performance. So very important that, knowing that this is the overhead. Right. Now, when this context switching can happen? So one is we can have higher priority processes, which means CPU have to immediately attend. Then when there's an interrupt means again somebody is asking immediate attention. And use and kernel mode switch preemptive CPU schedule use. That means there are some scheduling techniques that we will discuss. So if it is used preemptive CPU scheduling, then context switching happens. Now let's look at this graphic to explain you, right, what will happen. Now let's say we are working on a process P node. Now CPU is working on process P node, right? And then immediately operating system will generate an interrupt or system call, which means we have to stop at this point and we have to execute something else. So whenever this information came, you are going to save the current state in PCB, right? We have, right, process control block. So there you are going to keep all the information. Now, once you do that, you load the state for the next process, that is, let's say process P1. So we'll stop the process P0 at this point, and then we start it here, right? Now, once you finish done this execution of process P1, then again you state save process control block 1, and then you can go back to the previous process where you can reload the information from process control block 1. So what happens? You keep on executing at this point. It will change it here, finish, and again here. So you can see there are some idle times which actually are waste. Waste means, okay, there's no useful work has been done during this time. So it's basically a waste of information and resources. තාන්ත එක තේරුණාද මම ආයෙ පාරක් එක්ස්ප්ලේන් කරන්න වේද?
තේරුණා සර්.
එනස් අපි සරලව සමරි එක ගත්තොත් process දෙකක් මේකේ තියෙනවා, process P node සහ P1 මේක switch වෙන හැටි කරන්න කියන්නේ. එතනදී අපි කිව්වා process P node එක නවත්තනකොට ඒකේ තියෙන state එක අපි process control block 0 කියන එකේ save කරගන්නවා. එහෙම කරලා අපි process control block B1 එකෙන් ගන්නවා process P1 වලට අදාළ තොරතුරු ටික. ඒක ඉවර වෙනකන් execute කරලා අපි ඒ තොරතුරු ටික ආයෙ පාරක් PCB1 වල save කරලා PCB node වලට ගිහිල්ලා අපි නවත්තපු තැන ඉඳන් පටන් ගන්නවා. Simply diagrams tell how exactly context switching happens. Right. Now, according to the above figure, after an interrupt execution of process P node is halted. Now, usually interrupt means getting a priority. So getting a priority means we have to stop P node. Then operating system saves state information into PCB node. So all the information that we need to repeat or continue, we have to keep in a PCB node, process control block 0. And then you have to get the state for the next process from different process control block, which we call PCB1. Now, once we do this, CPU can execute the process P1, and then after finishing, you can save the state back in PCB1. Once this is finished, you can start from the first process, right, by loading the data from PCB node. Right? Okay. Is it clear, Puti? එතනට එනකන් ඒක පැහැදිලිද?
Also,
right. අපි තියරි ගොඩක් කරන මේ ටික හිමින්සරේ ඔයා ලියාගන්න. ඒ අතරේ බලන්න මොන හරි තේරෙන්නේ නැති දෙයක් තිබුණොත් මට මගෙන් අහන්න ඕනේ. ඒකේ මොකද්ද වෙන්නේ කියලා. මොකද ඔපරේටින් සිස්ටම් ක්වෙස්චන්ස් බලද්දි ඔයාලට තේරෙයි තියරි වලින් තමයි අපිට ගොඩක් ලියන්න තියෙන්නේ. ඔක්කොම පාඩම් කරන ඔක්කොම ගොඩක් වැදගත් නෑ. නමුත් සමහර ඒවා නිතර නිතර අහනවා. මම ඒවා තමයි අර නිතර නිතර කියලා දෙන්නේ. උදාහරණයක් විදිහට මම ඉන්ටරප්ට් කියන වචන කීප සැරයක් කිව්වා. විභාගෙදී අහන්න පුළුවන් what is an interrupt කියලා. අනේ වගේ. Right. Next one, we are going to take process schedulers. Now, I told you, whenever you have multiple processes, there should be a schedule. Who's going to go next? Ne? Process කීපයක් තියෙනකොට කොයි එකද අපි execute කරන්න කියන එක අපි දැනගෙන ඉන්න ඕන. Right. Now, when a program manager wants to handle what is running, we need to select another process to run based on some strategy. We have to have some mechanism. Right. Now, why this is important? First of all, we have to maximize number of interactive users. So you have to, interact. Then the second one is you have to maintain priorities. There are some priority. Some processes need priority. So which means the scheduler is responsible for scheduling this. Now, there are several process schedulers we can talk about. Mainly, we are going to talk about three schedulers: long-term, short-term, and medium-term. So let's look at what a long-term scheduling means. Now, when I say long-term schedule, right, so we will look at how the programs are admitted, and then it depends on the number of times that it's waiting, and then they load into queue, and then load them into memory for execution. So this is less frequent. Long-term means, right, which programs are admitted to the system for the processing. So depend on the order, you can do this. Second one, short-term scheduler. Short-term scheduler means when you want to have the time, right, then we can run very frequently. So this is good whenever you want to improve the performance. Third, medium-term scheduler. So we can handle these swap out processes, right? So for example, when you have running process, it can become block process, which you need to, get the information from the input-output device. So let's compare the three. The long-term means this is known as a job scheduler, and then the strategies selected processes are allowed, and you will have a full control. Then short term is known as CPU scheduler. So there it will take the processor from the waiting state and let's control. Third, medium term. So this is known as swapping scheduler. And then we will take process and then put into a main memory. So this is a reduced level of multiprogramming, right? So now we discuss how processes are scheduled. Right. Now we are going to use several terms when we talk about. We will talk about one is called a turnaround time, response time, throughput time, and waiting. So when we talk about the process scheduling, we use some terms like burst time, arrival time, exit time, waiting time, response time, turnaround time, through output time are very important. So let's look at a couple of them. When you say burst time, BURST, burst time. So when you say burst time, is the total time taken by the processor for execution on the CPU. So what is the total time it takes? Right? Then arrival time, the time when the process enters into the ready state. I told you it enters to the ready state, right? And ready for execution. So now let's look at these three processes. process P1. So its arrival time is 0. Immediately, we got it. Right. Now, in these three processes, you can see P1 enters 0 millisecond, that is my arrival time. Burst time means the execution time, right? So 8 milliseconds, for example. Then process P2 came around like 1 millisecond. Burst time is about 7 milliseconds. Third process, P3, 2 milliseconds. And the burst time is around like 10 milliseconds, right? So this is sometimes, right? Then there are other times as well. Exit time, the time when the process completes the execution and exit from the system. That means it complete everything and remove. Next, response time, the time spent when processing the ready state and get the CPU for the first time, right? Now, when we create a new process, it will go to new, then it goes to ready, and then it goes for running. So the time you need to go from ready to get the CPU means running state, we call response time. So these times are important, and we will work on a couple of examples later on. Right. Next, we are going to move on memory management. Now, I told you when you work with processors, you have to allocate resources. Allocating memory is important, right? So whenever you run a program, you have to load it into the memory. So when you say loading, means you bring the program from secondary memory, hard disk, to main memory. Because whatever the program code is saved in the hard disk, and then you have to get it to the main memory, and this is called loading. Second one, will linking. Linking means you get links between the modules, right, to continue the program execution. So if in a diagram, if I show you, this is what will happen. So we have a linker and we have a loader, and once you take everything together, you will load into the main memory. So loading this entire program into memory before start a program, we call static loading. So some places, especially the program is not very large, then you can process everything at once. And if you're taking everything before the program execution, we call static loading. But let's say, depend on the demand you are going to load, then we call dynamic loading, right? And then statistically linked program take a constant loading time. But if you have dynamic linking, it perform at the runtime. So in memory management, we are going to discuss how you may control, how you may coordinate memory systems and optimize all the system performances. So this information we want to keep. We want to keep what are the locations of the main memory. We want to keep memory location that already been used. That means we have already processors. Then allocation of main memory for a process. And then we have to keep track of capacity of finished processes. Right. Next, look at the memory allocation. Right. So depend on your requirements. If you are like allocating memory, we call memory allocation. And then whenever you have swapping, the term swapping process mean, right, if you do not have enough space in the main memory, then putting into the secondary storage, we call swapping. Right. Now let's give you an example. What will happen? So main memory, usually you have multiple processes. So let's say in this example, you see, we have process P1, we have process P2, and so on. And here, for example, if you want to save some money, save some space, then you can put process P1 to secondary memory or that storage. This is called swap out because you put P1 here. And then you put P1 here and then take whatever the process in the secondary memory to the main memory, we call swap in, because this is swap out, going from main memory to second memory. Getting from second memory to main memory, we call swap in. Then you have process P3. So after input and output, then you can put it again back here. And then you can take the process P1 in. So this is how it works usually, right? So usually there will be a memory. We have two partitions. You have low memory and high memory. Low memory, usually we will keep the operating system. High memory is for other user processes. Right. Now let me discuss another idea of memory fragmentations. Now, whenever you work with a memory, you allocate memory. Whenever you finish the work, you remove it. What happened after some time, memory is divided like this. You can see one place, right? The memory is available and there are some spaces and then memory and so on, right? The memory free space is broken into pieces. So a free space here, we have free space here, here, and so on. So what we need to do is we compact it. When we say compact it, what happens? Basically, you will put everything, the free space is taken to one place. And this is exactly what you see here. Right. Now, there are two types of fragmentation. The external fragmentation means you don't have not enough space, adjacent area. And the second one we call internal fragmentation, right? And then memory block assigned to the process is bigger. Some portion memory is left unused. So if it is a large one, then memory is fragmented. Now, when you want to take the values into one single place, we call compaction. Empty spaces, we have various reasons there are to get this one. And then what we are going to do is we are going to create a single block of free memory. And this is called compaction, right? So this is before compaction and this is after compaction. Right. With that note, I think it's too much otherwise if I continue the last part. What is left is a couple of points to finish the operating system note, which I think we can do it by next week. එහෙනම් පුතේ මං හිතනවා